our moonwalker. We use it to simulate reduced gravity. And the way we do that is through the equivalence of gravity and force, we can use springs to apply a load on the body. And so you can see there's this device overhead here. We have a harness that hooks up to that. And then you see this spring here. The idea of this system is that it provides an approximately constant force. So that means we can simulate walking and running not just in one gravity like now, but if I wear the harness, we can pull up with a certain force to achieve Martian or lunar gravity. You can see I'm walking here. This is about 2.5 miles per hour. And I can tell you that if I was in lunar gravity right now, I would be running, but not on Earth. And that has to do, there are some parameters that control, that predict whether we're walking or running. One of them is called the Froude number. And these parameters include gravity as a term. So gravity has an effect on when we walk and when we run. And as we talked about, that also has an impact on the energetics, how much energy we're using per time or per unit distance. So if I go a bit faster, well, now I'm at 4 miles per hour, and I'm almost running. I think it's a little bit harder to run. Probably the run-walk speed is a little bit faster. Here's 4.5, and now it's easier to run. You can see this is very loud. Part of that's the treadmill, part of it's just the design of this exoskeleton. In lunar or Martian gravity, you wouldn't hear this clapping because the loads would be lower. So let me go ahead and go back to a walk. That was 4.5 miles per hour. Without the exoskeleton, I might still walk at that speed, but with it, it's probably easier to run.